how you can't just buy one shoe?
You walk into a store and you have to buy a whole pair of shoes, even if you only wanted the left one. Well, it's the same way when you want to create matter.
Let's dive right in.
This equation states that if you have enough energy, you can actually create mass.
But since C is such a big number, it takes a lot of energy to make a little bit of matter, which is why elementary particles are so small.
All the known matter in our universe is made up of baryons, like protons and neutrons, which are made up of 3 quarks each. Particles that don't contain quarks, like electrons and neutrinos, are so small that their mass is considered negligible. But there's something missing. Just like how right and left shoes come in the same box, every quark is created with an anti-quark counterpart, which has the same mass, but the opposite charge.
I cannot exist in a world with you in it. Then be destroyed!
When matter and antimatter are near each other, they annihilate, turning back into the energy that formed them. So if quarks and antiquarks were really created in a 1-to-1 ratio, they would all have annihilated by now, and there would be nothing left in the universe but energy. That's the paradox of baryonic asymmetry. Clearly, there's more baryonic matter than antimatter in the universe, even though that shouldn't be possible, so what actually happened? Well, let's go back a few billion years. Right after the Big Bang, there was so much energy packed into the teeny tiny, extremely dense universe that quarks and antiquarks were able to pop in and out of existence whenever they wanted.
Most scientists believe that under such extreme conditions, matter could somehow be produced from antimatter or even created all on its own.
But within the first second of the universe's existence, it expanded so much that this was no longer possible. By the end, there were 1,000,001 quarks for every billion antiquarks, and those 1 in a billion bits of matter went on to make up everything. So be thankful for the universe's little asymmetries. After all, the biggest little asymmetry of all is the reason we exist.